Hi there, everybody. So we're going to be doing notes on a video format today. Your notes are and homework all follow in Google Classroom, and so they're posted in there. I'm going to ask you to also do a paradox after you see some of these notes, so please be aware of that. All right. The topic today is like stuff we've worked with a little bit, and they're just different forms of equations. You're going to be doing just some math work to move them into one form or another. So there's multiple forms of equations, but we're just going to be using two. Okay, and you've seen times when it's able to work with different equations in different ways, and sometimes it makes it easier to work with one, if we just do a little bit of work and move it around. If we're going to graph, it might be easier to have a y equals, so I can plug it into the calculator, make a table, find the slope and y-intercept, that sort of stuff. So all we're going to ask you to do, you're going to be asked to move things around. So like adding, subtracting, multiplying, dividing, that kind of moving around. Maybe some distributing to work in two forms. So the first form is referred to as slope-intercept. And this usually comes up a lot when I say, what's the slope? Y equals mx plus b. I'm sure that's totally familiar. Where m stands for the slope, it's the rate of change, it's the rise over the run. When you make a graph, it's how fast it goes up versus how fast it goes side to side, or how fast it falls. So we have a number here for slope, and then we also have this number here for the y-intercept, which is 0 for x and some number for y. And actually down here on the first thing, you're going to be asked to do first A, B, and C here. You're going to ask to put them into slope-intercept form. So we're going to have a y equals when we're done. The next one, I believe I did introduce in the notes a few weeks ago, but there's a lot of information going on. So here it is again. AX plus BY equals C. Oh, geez, what am I doing? This is called standard form. Okay, and these are just the names. The names of it, it's not like, if I say one or the other, just being able to go from these are actually the two that you're going to go from one to the other, where A, B, and C, these are all A, B, and C are number values. And specifically, they're integers with no fractions, which makes a lot of people happy. So no fractions. But if, of course, we do encounter a fraction, we're going to just be able to multiply through. So that's where the distributing property is going to be important. And we also like to keep A as a positive value. So if you see a negative with the A, you're going to just simply, real quick, just multiply everything through by a -1. And really, it's the same if you would have moved everything to the opposite side of the equation. So it's just kind of like we're flip-flopping things. We just multiply through by -1, and that happens every time. There's no change like conditions. If you do this, you do that, or this happens, you do that. All right, so these are the two we're working with. Slope-intercept form is y equals mx plus b. So we want to get the we want to get the y by itself. So when you look at this first one, we have a number here to distribute. So when we do this, y sits there. The 7 comes down. We distribute that first. And we don't have to do a whole bunch here. We're going to combine our numbers. That can be combined. I have 3x sitting by itself, so that's going to stay like that. So I get y equals 3x minus 29. So there we go. That's not too bad. When you look at the next one, it kind of starts out the same way. You have some distributing to do. And you also see probably you've moved a number like 12 over. We can do that. We've done that lots. Different ways for different times. Okay, so I distribute first. I get 10x plus 30. Now I need to move that 12 over, so I, just add it. Now I got to decide what to add it to. If it has an x, we put it with the x. If it doesn't, so I'm going to put it with the 30, because we always need to look for like terms. Okay. Oop. There we go. Oop. Now, distributing, no problem. Adding 12 over, no problem. On this next one, we don't have any distributing to do. All right, so we need to get the y by itself, which means if there's an x over there, we need to move it over or subtract it over to the other side. Okay, so just like you did the 12, if it's a minus 12, we add it over. Since this is a positive 13, I'm going to subtract 13. Now subtract 13. I want to be careful not to combine it with the 14 because this has an x and that doesn't. All right, so I get 2y equals, I'm just going to write it down as 14 minus 13x. Perfectly acceptable to write it as negative 13x plus 14. That's fine. Now, stuff you've done before is like, I need to get the y by itself. So how do we do that? Well, if there's multiplying, we divide. You do not get to pick and choose what to divide. If you want, it's like distributing. If you distribute to all. If you're dividing, you divide all. All right, so I get y equals 7. Now, I'm going to leave 13 over 2x. I'm going to leave that as a fraction. That doesn't bother me. If you want to write it as a decimal, that's okay. Y equals 7, what is it, 6.5, I think? Okay, or you can write negative 6.5x plus 7. These can be rearranged, and so the x is first if you like, or the negative 13 over 2. Just so it's you keep the positive and negative signs with the numbers. Okay. Now, any one of those, totally acceptable. Do not give me every possible answer for a problem. I'm just looking for that you can do the work, get to one. That's all. Don't say this or this or this or this. Okay. Now, standard form, I want ax plus by plus c. I want x's and, oh, geez, Pete's. I don't know where 7 came from. I want ax plus by. I said it, and then I wrote something totally different. That's all right. There we go. Ax plus by equals c. Now you see this problem. It starts off exactly how the other one did, but we're asking you to, do the work to make it look a little different. All right. So same thing. Distribute though. Do that. Same thing, combine the numbers. So y equals 3x minus 29. Now I'm going to rewrite it here just so I have a little room. Now the thing is, I want it to look like this, so the x's and y's are on the same side. All right, so that's where I move the x over. So again, this is just the adding and subtracting stuff. I want to move this whole thing over, so this is positive, so I subtract it. No, this is positive y, so I write plus y. And then my last thing here, now we want a to be a positive, so we want the number with x to be positive. And this is where I was mentioning, if you need to get that to be a positive and is currently a negative, we're just going to multiply, we're going to just multiply through here by -1. Okay, so multiply everything by -1. And that really means just distribute to everything. It means everything flip-flops. So I get 3x minus 1y, or minus y equals, and that flip-flops to positive 29. All right, on this next one, we're going to distribute again. Same kind of thing, y minus 12 equals 10x plus 30. Now this is the same thing where I need to move the 12 over, so it's a minus 12, so I need to add 12. So I get y equals 10x plus 42. Now I need to move the 10 that way, so it's a positive, so I want to subtract it. Now I don't want to combine it with the x, so leave them separate. I don't line them up because I don't want to confuse myself that I want to come with the x and y to go together. So I have, moving over here, negative 10x plus y equals 42. Okay, and above, I wanted to get rid of the negative here. So if I want to get rid of negative, same thing, I just multiply by negative 1. Okay, so to get positive 10x, I get, instead of positive y, I get minus y, and I get minus 42. All right, this last one here. So I don't have any distributing to do, but oh, you see that fraction, you know it's going to come up. That's how we roll sometimes. So the y's are over here. I want to move the x's over there to join them. So just like we did above, when it was 10x, I wanted to move it. I subtracted it. Even in fraction form, I do the same thing. Minus 3 over 2. So even as a fraction, I'm going to just do the same thing. If it's a positive, I subtract it. So I get negative 3 over 2x plus 4y equals, and that's a negative 10 still. Now here was the thing. When you have a fraction, I want to multiply everything by what's there. It's not like you have to figure it out. You don't have to go back and, what's the calculation for it? If I want to get rid of the fraction, I multiply by what's in the denominator. So I'm going to multiply everything here by 2. Now here's the other catch. Because there's a negative and I want to cancel it out, the 2 will cancel the bottom, and I want to also distribute a negative with it. Because I want to do, you can do it in pieces, multiply through by 2, and then multiply through by negative 1. Or you can just say, okay, what's in the denominator? And I need to cancel out that negative. So when you do this, distribute everything. Okay, negative times the negative makes it positive, so it goes away. 2 times 3 is 6. 6 over 2 in the bottom. Plus, or I guess it's negative 8y equals positive 20. Okay, and then this thing is, what really happens is the 2 and the 2 cancel each other out. So ultimately I have 3x, and you can write minus 4y equals to 20, or plus negative is also fine. Okay. All right, after this, so I'm going to post a thing to go to Pear Deck and on your own, go through those problems and show me what you can do and how you're feeling about this stuff. The homework is here. It follows the notes. It's 1 through 10. So again, you'll see similar to what we did. Put them in slope-intercept form, put them in standard form, and then just review some graphing because we're coming up to a test next week. All right. Let me know if you have questions. Email me, kkamai@maine207.org. Talk to you soon. Bye.